Welcome to the Chemistry Lab. In this video we will be discussing the periodic table, atomic structure and isotopes. So everything in the universe is made up of different elements, and we organise these elements in the periodic table. Now, the periodic table is arranged in order of increasing atomic number, starting from 1 up at the top left and going all the way up to 118 at the bottom right. The atomic number also tells us how many protons there are in an individual atom. The periodic table is arranged in 2 dimensions. Going horizontally, we have the periods. These resemble rows, and these increase in terms of the atomic number, in terms of the number of protons, going from left to right. Now, vertically, the periodic table is arranged in what's called groups. Each group collects elements with similar chemical properties to one another. For example, on the far left we have the alkali metals, and all of these react rather violently with water. As you go down the group, they get more and more reactive. On the other hand, the halogens, on the second from the far right, as you go down the group, they get less reactive, but they have similar chemical properties. And the reason for this similarity lies in the number of outer electrons they have. Each element in each group has got the same number of outer electrons. The halogens, for instance, have got 7 outer electrons, whilst the alkali metals have got 1 outer electron. So let's dig a little bit deeper in terms of the atom itself. Now, each element is made from totally different individual atoms. This example we have here is of the lithium atom. We know that it is lithium because the nucleus is containing 3 protons. The atomic number for lithium is 3. The number of protons is what gives the atom its identity. Now, the central part of the atom we refer to as the nucleus, but the electrons are found in orbitals, where they orbit around this nucleus. The electrons have a negative charge, whereas in the nucleus we have an overall positive charge, and that positive charge comes from the protons. Also in the nucleus are the neutrons. However, they do not have a charge. They're described as neutral, hence the name neutron. And this table here summarizes those key points. Now, each of the particles has a slightly different mass. However, the protons and neutrons have a relatively similar mass that we can simplify down to just 1 atomic mass unit, whereas the electron, its mass is almost 0. In fact, it's almost 1/2000th of the mass of a proton. Protons have a positive charge, and we say its charge is +1. Neutrons have 0, whereas the electrons have got a -1 charge. Now, we've looked at the atom in its basic structure, but we're going to look now at the electron arrangements of these atoms. So, the first example here is out of carbon. We describe its electron arrangement as 2-4. The reason for this is there are 2 electrons in its first orbital, and there are 4 in the second. Oxygen has an electron arrangement of 2-6, because there are 2 in the centre and then 6 in the outer orbital. However, sodium is 2-8-1. Now, this comes from the fact that there are 2 in the centre, a full octet, or 8 electrons in the middle orbital, and just a single electron in its outermost orbital. The mass number of an atom, or rather of a particular isotope, comes from the number of protons and the number of neutrons that are present in that particular atom. Now, the reason we can do it this way is because the mass of protons, as we saw earlier, is equal to 1 atomic unit, and the mass of neutrons is also equal to 1 atomic unit. So let's take an example here. We have a lithium atom that has 4 neutrons and 3 protons. What is its mass number? Well, it's a simple case of just adding these 2 numbers together. 3 protons plus 4 neutrons is equal to 7 atomic mass units. So what we can also do with this is we can use the same equation, if we rearrange it, to work out the number of neutrons. And we simply take the mass number and subtract from it the number of protons. So let's try this out in an example. So work out the number of neutrons in an atom of iron that has a mass of 56 AMU. So for this, we're simply taking the atomic number of iron, which is 26, which is also going to give us 26 protons. We've got the mass number of 56, so we simply take 26 away from that 56, and we're left with 30 neutrons. Now all of this information can be concisely contained in what's called nucleotide notation. So let's take the example of carbon here. So carbon has the element symbol of C. It has an atomic mass of 12, and it also has the atomic number of 6. So we label it like this, with our mass number held up at the top and the atomic number at the bottom. Now why would this be of any use to us? Well, it just so happens that there are many different types of elements known as isotopes. So carbon has 3 main isotopes: carbon-12, carbon-13 and carbon-14. Now you'll notice from this that each of these isotopes has got the same atomic number, which basically means it's still carbon. The only thing that's different here is the mass. So if the atomic number remains the same, that means the number of protons is going to remain the same. So the only thing that's differing here is the number of neutrons. So an isotope is an element that has a different number of neutrons than other examples of that same element. Now there is another variant of an atom, which is known as an ion. So an ion differs from a normal atom in that it has a different number of electrons. They are charged atoms. So here we have once again the lithium atom, and there is its nucleotide notation. Now when this lithium atom loses an electron, it forms a positive ion, and the reason for that is we now have 3 protons and 2 electrons, so we have 1 proton more than the number of electrons we have. If we take away another electron, we have a lithium 2+ ion, because we have 2 more protons than we do electrons. And if we take away that 3rd electron, we've now got lithium 3+, because we have 3 positive protons and no electrons. Now the opposite principle can happen as well when we have negative ions forming, and this occurs when atoms gain electrons. So let's take the example here of oxygen. Oxygen, as we learned earlier, has 6 outer electrons. So if we give it an extra one, it's now got a negative charge. If we give it a second additional electron, it's now got a 2- charge. So that brings us to the end of this mini tutorial. If you have any questions with regards to these sort of topics, please feel free to leave them in the comments below.